6.4 Equations involving inverse trigonometric functions. So solving an equation for a specific variable. We're going to solve y equals 3 cosine 2x for x, where x is restricted to the interval 0 to pi over 2. So what are we trying to do? What's the goal here? So our goal is to get x by itself. So we want to get everything we can away from it. So the first thing we do is always move that number in the front, that coefficient in front of the function. Get rid of it. We can divide everything by 3. So when we do, we have y over 3 equals cosine 2x. Now we need to move the function. You can't divide by 2. You can't divide by 2 because this is cosine 2x. So we have to get rid of the function first before we talk about that 2x. So we need to move it over. Remember, to move it over, we take the opposite of it. We take the inverse. So you can either use arc cosine or cosine little -1 thing. That just means inverse. But we're going to use arc cosine because it's just easier to write. So when we move it over, it becomes arc cosine y over 3 equals 2x. So now we can get rid of the 2x. We can get x by itself. But we're not going to divide by 2, because if we divide by 2, the answer is because it's just going to look horrible. So instead of dividing by 2, we're going to multiply by 1/2. Because remember, dividing by 2 is just multiplying by 1/2. So we're going to multiply both sides by 1/2, and what that's going to do is just get rid of our 2. So we have 1/2 arc cosine y over 3 equals x. And yes, that's our answer. Or if you used the other version of inverse of cosine, it would be 1/2 cosine, inverse of cosine, y over 3 equals x. So the reason why we don't divide by 2 because our answer would look like this. That just looks horrible. We don't want an answer like that. We like to do by halves. So that's why we multiply by 1/2. And yes, you are wrong if you do this. You need to multiply by 1/2. It sets us up later in calculus for something. Alright, let's solve an equation involving an inverse trigonometric function. So we're going to solve 2 arc sine x equals pi. Alright, so again, we're just trying to get x by itself. So always move the number in front first. So the number in front is 2. Let's get rid of it. So we're going to divide by 2. So we have arc sine x equals pi over 2. Now we need to move over the trig function. So to move it over, when we move it over, we take the inverse. Since it's already the inverse, it actually becomes the normal sign. So we're going to move it over, and when we do, we have x equals, so it becomes sine pi over 2. Now on our unit circle, we have that. We have sine on our unit circle, sine pi over 2. So sine pi over 2 is on the unit circle, and it equals 1. It's 90 degrees. So we can switch this to x equals sine pi over 2, which is 1. Now we have to check it because we actually got a value. We got a value for it, so we need to check it. So there's 2 ways you could check it. You could do it by hand, or you can use a calculator. It honestly does not matter. If you do it by hand, I mean, it's great, but just to me, it's just easier to use your calculator. So our equation, we have 2 arc sine x, which is 1, and it needs to equal pi. So when we simplify this, it needs to make sure that it equals pi. So arc sine 1 is pi over 2 equals pi, so pi equals pi. It works doing it by hand. But if you wanted to use your calculator, just literally plug it in as your calculator. So your calculator doesn't have arc sine, but it has inverse of sine. So if you use your calculator, it would be 2 inverse of sine 1, and then you plug that in. So that's the left side. So the left side, if you plug that into your calculator, we get 3.141592654. That's pi, by the way. And then the right side, so that's the left side. The right side is pi. So if you plug that into your calculator, pi is 3.141592654. So they both sides equal. So we're good. This is an answer. So 1 is an answer. Example 3. We're going to solve inverse cosine x, inverse sine 1/2. So both sides are inverses. So moving is not going to do us any good. So when both sides are inverse, we need to use something called u substitution. So we're always going to work with the side that has that value. So the side that has the value is sine. So what we're going to do is we're going to make it equal something. So what we're going to do, what we say is we're going to let inverse of sine 1/2, we're going to make that equal u. Whatever u represents, it's inverse of sine 1/2. We do know that. It's going to equal something. So let's replace it back. So we have inverse of cosine x equals inverse of sine 1/2, which we just said is u. So we can actually get x by itself by moving it over, right? So we have x equals regular cosine u. Now we need to solve for x. How the heck do we do that? Well, we're going to draw. It's been a while since we drew some pictures. Now, why are we allowed to do this? Well, remember back in college algebra when you tested for symmetry, you tested for even odd functions? That's what we're doing here. We're allowing something to represent a variable. We are allowed to say, whatever this is, it's going to represent a. Whatever it is, it's going to represent a. So a could be anything. It could be the sector length of between two cities. It could be, in this case, inverse of sine 1/2. We're just making it represent a variable. Because that's what a variable is. If I say x is 1, that is saying x is 1. So I can either use x in my equation or I can use 1 in the equation. That's what we're saying here. So that's why we're allowed to do this. So we're working in quadrant 1. How do we know that? Using cast. We're working in quadrant 1 because sine is positive. It's sine 1/2, so it's positive. So we're working in quadrant 1. So what we're going to do, we're going to sketch u in quadrant 1. So we have our quadrant 1. And remember what u represents. U represents the inverse of sine 1/2. So our values are 1/2 for sine. So that means opposite over hypotenuse. So 1 and 2. We find the missing side using the Pythagorean Theorem. So the missing side is square root of 3. Alright, so now that we found our missing side, we can go ahead and find cosine of that value, because that's what we're trying to find, right? Is cosine of u. This is u. This picture represents u. It represents inverse sine 1/2. So the cosine of this, so cosine u is adjacent over hypotenuse, so square root of 3 over 2. Example 4. We're going to solve arc sine x minus arc cosine x equals pi over 6. So let's isolate one of the inverse functions. That's usually what we try to do. We try to get something by itself, so that's usually a good step. So when we add arc cosine x to both sides, we're left with arc sine x equals arc positive arc cosine, so arc cosine x plus pi over 6. So now we need to, I want to still solve for x. We can get at least one x by itself, and that's our goal here, is to get at least one x by itself. So I need to move over the sine function. Now I can't divide it out, and there's no plus or minus, so remember we take the inverse. So we're going to take the inverse to the whole thing to the right side. So we have x equals the opposite of arc sine, which is sine. Then we have arc cosine x plus pi over 6. So we don't have a value here. We have pi over 6, but arc cosine doesn't mean anything to us, so we're going to use our u substitution. We're going to let u equal arc cosine x. So anytime we do u substitution, that's when we start to draw some things and stuff like that. But before we get to that, arc cosine, that function using cast, it yields angles in quadrant 1 and quadrant 2. So quadrant 1 is 0, and then quadrant 2 is all the way to pi. So we're working between 0 and pi for our values. So we said u is going to represent arc cosine. Let's switch it back. So we have x equals sine arc cosine x, which we said is now u, plus pi over 6. Now do you see something that we have sine a plus b? We have a sine sum identity. So we have a sine sum identity. Say that 5 times fast. Whew, that's a tongue twister. Sine sum identity. So let's use our sine sum identity. And we have our a and we have our b. So we have x equals sine a, which is u. Then we have cosine b, so cosine pi over 6. And that's going to be plus cosine a, which is u. And then sine b, which is pi over 6. So now we have our formula. We just need to find the values. Alright, so we're going back to chapter 4 here. Remember from chapter 4 when we graphed? So from sine, arc cosine x plus pi over 6, we use the fact that the range is negative pi over 2 to pi over 2 for sine. That's going to help us find some values here. So we have our range from negative pi over 2 to pi over 2. And now we're saying that this range comes from the sine arc cosine plus pi over 2. Sorry, plus pi over 6. Plus pi over 6. So we're saying we need the sine of this, all of this. We need the sine function of arc cosine x plus pi over 6. So whatever it equals, it needs to be, so whatever this is, when we find arc cosine x plus pi over 6, whatever it is, the y value needs to be in between negative pi over 2 and pi over 2. That's the rule. So we can solve for it and find our, kind of like our parameters. So we subtract pi over 6 to both sides. We're left with negative 2 pi over 3. Arc cosine x, and that's less than or equal to our pi over 3. Alright, so don't forget, we're actually working with arc cosine here. It tells us right here that we're working with arc cosine. So since arc cosine, that range of arc cosine is 0 to pi, go back to 6.1 for that. And then we found, specifically for this example, that it should fall between negative 2 pi over 3 and pi over 3, u lies in. So because this comes from what we're given. But in reality, arc cosine is only between 0 and pi. So pi over 3 falls in between pi, but not the 0. The 0 and negative 2 pi over 3, those don't work. So it can only go from 0 to pi. So u lies between 0 and pi over 3, which is in quadrant 1. So we're working in quadrant 1. So what we do, let's sum it all up before we actually start solving. So we isolate the function. We'll isolate any function. The reason why we did cosine is just because to keep it positive, that's all. So then after that, we solve for x. We get sine arc cosine plus pi over 6. So it's telling us I want the sine of, so I want the opposite hypotenuse of arc cosine x plus pi over 6. Anytime we have an arc cosine or an arc sine, an inverse function, when we're trying to solve for stuff, you're always going to do that u substitution. So we say u equals arc cosine x. So we replace it back. Now remember, the arc cosine function yields angles in quadrant 1 and quadrant 2. So we know somewhere in here our final answer is going to be in Q1 or Q2. So we replace the u back, and we see that we have u plus pi over 6. That's a plus b. So we have the sine sum identity. We replace it with our sine sum identity, saying so x equals the sine sum identity. So x equals sine u cosine pi over 6 plus cosine u sine pi over 6. So from sine arc cosine x plus pi over 6, we use the fact that the range is pi over 2, negative pi over 2 to pi over 2 for sine. So that's what we know about sine, because we want the sine function of arc cosine x plus pi over 6. So whatever arc cosine x plus pi over 6 is, it needs to be in between negative pi over 2 and pi over 2. So whatever it is, it needs to be in between negative pi over 2 and pi over 2. So we solve for that function, and we get negative 2 pi over 3 to pi over 3. But we're working with arc cosine. Because we're working with arc cosine, that range rule is 0 to pi. Negative 2 pi over 3 is not in between 0 and pi, so we can't use that. Pi over 3 is in between 0 and pi, so that means what we're working with is going to fall between 0 and pi over 3, which is in quadrant 1. So that's why we draw quadrant 1. So what we're working with now is 0 is less than or equal to arc cosine, that's less than or equal to pi over 3. So we have a cosine function, and we have a value. It's x. So remember, cosine is adjacent over hypotenuse, but we're also given the x of that cosine. So whatever it is, it's x, so x over 1. So the adjacent is x, the hypotenuse is 1. Now we need to find the other missing side. So we use the Pythagorean Theorem. So using the Pythagorean Theorem, we find our missing side. So using the Pythagorean Theorem, our missing side is 1 minus x squared. It's positive because it's going up. So it's positive because it's going up. So now let's go back to our sine identity. The identity we came up with way at the beginning. So which is x equals sine u cosine pi over 6 plus cosine u sine pi over 6. So using our picture, we can get cosine and sine u. So let's go ahead and do that. Let's just make it known right now what sine u is and what cosine u is. So sine u, so that's opposite over hypotenuse. So sine u is square root of 1 minus x squared over the hypotenuse, which is 1. So it would just be square root of 1 minus x squared. So that's what sine u represents. Now we need to find cosine u. Remember, this picture represents u. So cosine u, it's adjacent over hypotenuse, so which we already have, it's just x. And then for our other values, we just use the unit circle. So we have x equals sine u, which we found to be square root of 1 minus x squared, times cosine pi over 6. So cosine pi over 6 on the unit circle is square root of 3 over 2, plus cosine u, which we said was just x, times sine pi over 6. So on the unit circle, sine pi over 6 is 1/2. So from here, we need to solve for x. We have two x's here. So the first thing I want to do is just get rid of these fractions. I don't want to work with fractions. It makes my life harder, especially when we're talking about weird numbers and square roots and stuff like that. So we have multiple x's here. Let's get rid of these ugly fractions. So to get rid of the fractions, we can multiply by the reciprocal, which is 2. So we're going to multiply both sides by 2. So we'll have 2x equals the square root of 1 minus x squared times the square root of 3 plus x times 1. Because the bottom goes away. We don't need that 1. So see, it's a lot easier to work with because we don't have all the fractions. Now we can move over this x by subtracting it. So now we're left with x equals the square root of 1 minus x squared times the square root of 3. You see how we're getting there? This is algebra at its finest. Alright, so now that we got rid of the fractions and we have square roots, let's get rid of the square roots. So in order to get rid of the square roots, we need to square both sides. That's going to allow us to get rid of the square roots. So then we'll have x squared equals parentheses 1 minus x squared times 3. Because squaring it gets rid of square roots. We distribute the 3, so we have x squared equals 3 minus 3x squared. We need to solve for x, so I'm going to add 3x squared. And when we do, we have 4x squared equals 3. Divide by 4. So then we get x squared equals 3 over 4. Square root both sides. We get x equals positive negative square root of 3 over 2. Now, is it positive? Is it negative? Well, we're working in quadrant 1. Remember, we're working in quadrant 1. So in quadrant 1, it has to be positive. X is positive in quadrant 1. So it'll be x equals square root of 3 over 2. Now, we need to check our answer. So we always have to check our answer when we get a real number. So let's check it. So we're going to check it by plugging it into the original equation. So we have arc sine x, which is square root of 3 over 2. Then we have minus arc cosine x, which is square root of 3 over 2. And that's supposed to equal pi over 6. So using the unit circle, you're going to go to sine square root of 3 over 2 in quadrant 1, because we're working in quadrant 1, remember? And then you're going to go to cosine square root of 3 over 2 in quadrant 1. So using our unit circle, let's find these values. So with our unit circle, let's find the values. So for arc sine square root of 3 over 2, that means you're going to go to sine square root of 3 over 2 in quadrant 1. So sine square root of 3 over 2 in quadrant 1 is pi over 3. And then arc cosine, so cosine square root of 3 over 2 in quadrant 1 is pi over 6. So we have the two values now, pi over 3 and pi over 6. So cosine square root of 3 over 2 in quadrant 1 is pi over 6. Pi over 3. And then cosine square root of 3 over 2 in quadrant 1 is pi over 6. And when we subtract those, remember, it's supposed to equal pi over 6, so that's what we're checking. To let a reader know you're checking in math, you put a little question mark over the equal sign. That's how you do that. So pi over 6 minus, or pi over 3 minus pi over 6, we get pi over 6. So it does equal. Just in case if you're wondering how I did that, times 2 times 2, so we have 2 pi over 6 minus pi over 6, and that's how we get the pi over 6. So it does work out. That means our solution is indeed square root of 3 over 2.